All right, we're going to do a little review from yesterday. So you had this image in your notes, and we had this up on the board. We have the atom, and the atom has a couple key components in it. We're talking about subatomic particles. Okay, so first you have the nucleus, and the nucleus is the mass. So we talked about the mass number, and the mass number is simply the protons and neutrons because that's what's found in the nucleus. The neutrons have mass, and the protons have mass. The difference is the charges. Neutrons are neutral. Neutron, neutral. Protons have a positive charge. So my nucleus has an overall positive charge. My electrons are found outside my nucleus, and more or less, they do not have any mass. And the big thing with them, for us, it has a negative charge. So we're going to be taking that information today and talking about two extremely important ideas. So we will be discussing the difference between isotopes versus ions. Very intense stuff, I'm telling you. Very intense. If you're not in the mood, I don't know what. All right, so isotopes versus ions. Here are a couple of definitions you need to have. All right, an isotope is an atom with the same number of protons but differing numbers of neutrons. So I'll give you a second to write that down. Very, very, very important. As you're writing that, just think about what the definition is. I'm going to have the same number of protons, so that means it's the same element. Yesterday we talked about if it's the same number of protons, if the protons don't change, then it's always the same element. But if I have a different number of neutrons, then what am I changing? I am changing the mass because protons and neutrons are dealing with mass. So what is an ion? A little longer of a definition. An ion is an atom or a molecule which has gained or lost one or more of its valence electrons. We haven't talked about valence yet, but the key word is electrons, resulting in a net positive or negative electrical charge. So if I gain electrons or if I lose electrons, I'm going to be changing the charge because we talked about that electrons have a negative charge. Oh wait, don't protons have a positive charge? Yes, they do. So we'll talk about that relationship. So hopefully you have those two definitions down. So let's take a look at isotopes. So here are some atoms. Please, you do not need to write these down. We will be writing something down lower, but you might want to make a separate title, just isotopes. I don't think you're going to be able to fit it where you have your title. So what I have here, 3 atoms. You can see underneath, we have a word that says carbon 12, carbon 13, and carbon 14. You might have heard about these before. A lot of times it's dealing with like carbon dating or things like that. For some of you who may be familiar with the word isotope, you might be wondering why you know it. Well, one thing that you might have seen before, if you've ever watched The Simpsons, Springfield's baseball team called the Springfield Isotopes. There's actually a team in Arizona, a minor league baseball team that is also called the Isotopes. One of the big deals with isotopes is if it is not a stable isotope, then it can become radioactive. And what it means is if it's radioactive, the nuclei of an atom will basically break down and alpha, beta, or gamma particles will actually be emitted. And again, in The Simpsons, this is where you see this guy. You get to see the three-eyed fish. So that's kind of some randomness with isotopes. But what is an isotope? An isotope is the same element with different masses. So if it's the same element, check it out. I have 6 protons, and I'm going to show you how to write this in a second. 6 protons, 6 protons. It's up here too, 6 protons, 6 protons, 6 protons. So it's all carbon. But what's the difference? Different number of neutrons. This happens naturally in nature. It will happen naturally in nature. There is not one type of carbon atom in the world. There is not one type of chlorine atom. There are different isotopes. And what we do is we take the average. So if you look at this before we move on, this is what you look at the periodic table. It says carbon. And here's a mass. It says 12.0107. It doesn't weigh 12. It doesn't weigh 13. It doesn't weigh 14. But it weighs pretty close to 12. Well, what this is called the average atomic mass. We will be working on this on Thursday with M&Ms. But if it's an average of all the different isotopes. But if I have isotopes of 12, 13, and 14, and the average of those three, say it's 12.017, you'd probably think that carbon 12 is the most abundant isotope in the world, or in the universe, which it is. But how do we write this? How do we start to write the notation for isotopes? Regardless if you're kind of confused on what the heck of isotope is or not, let's talk about how we write an isotope. So what we would do, what I'd like you to do in your notes, please write 3 C's with a little bit of a space in between. There's an important thing that we need to do with these. So first, we need to put some numbers down. All right, so on the top, we are always going to write the mass number. On the bottom, we are always going to write the atomic numbers. So first, let's review. What is the mass number? What do we talk about? The mass number are the protons and the neutrons. So it's all the mass in my nucleus. So you got to make sure that you know that the mass number is the protons and the neutrons. What's my atomic number? The number of protons. It's the number of protons. So let's talk about each of those. So here's my carbon again. So what is the atomic number of carbon? It's 6, right? 6. Just like it says up here, 6. So that means for every one of these, is it going to be 6? Yes, they're all 6. So what we do is we always write the atomic number in the lower left. All right, but the mass number is going to be different. So there is a way that we write isotopes, and it's in the name. This says carbon 12, carbon 13, and carbon 14. So if you take a moment and look at those numbers and look at the protons and the neutrons above, that number looks like I'm adding the protons and the neutrons. So 6 plus 6 is 12. So this is carbon 12. I put the mass number right there. This is 13, and that is 14. So this is how we write isotopes. So what looks redundant? Atomic number, right? Technically, really, I don't even know if I need it. It's the number in the upper left that matters. That's the number that matters. What I like to do is fill out something below it. So you can either just even write P, N, and E, and we're going to make a little chart. So how many protons are in each isotope? All the protons are the atomic number. So it looks like I have 6, 6, and 6. Boom, I have 6 in each. We're going to go to the other one that we haven't even talked about. Hey, you're not talking about electrons. Right. Eventually, we're going to talk about it next, but a charge has to be here. An isotope is about neutrons and protons, different number of neutrons. So if there's no charge, meaning they're equal, my positives and my negatives are equal, that means my protons and my electrons must be the same. So those are 6 each. So what's left? Neutrons. I have a mass, I have my protons, so the neutrons are all the leftover mass that has not been accounted for. So this one I have 6 protons already. My total mass is 12. This includes the protons. So I should have 6 there. Here, 6 and 13. So I should have 7 there. And the last one, I should have 8. So please make sure you get that grid because that's really important. You got to make sure that you have an understanding of the protons, neutrons, and electrons when we're talking about isotopes. All right, let's look at ions. So make a little title says ions. And you do not have to write this at all. Please don't. But I have a picture. This one says this atom is neutral, negatively charged, positively charged. So let's look at it. Picture is not the best, but the description underneath works. So what do I have? I have 6 protons, 6 neutrons, 6 electrons. Kind of sounds like what we just did. Why is it neutral? Same number of protons and electrons. Okay, we'll write that down in a moment. This one says atom is negatively charged. If it's negatively charged, that means I have more negatives. Notice though, it says 5 protons, 6 neutrons, and 6 electrons. In this final one, it says this atom is positively charged, more protons than electrons. So this says 6 protons, 6 neutrons, 5 electrons. So first, let's talk about what atom is being represented in each of these. And I want to write this down, okay? And if you want to write these little titles, this title's good. You could even just write neutral, negative, positive, or negatively charged, positively charged. So I have 6 protons, 6 neutrons, 6 electrons. Which one matters? Protons, neutrons, or electrons when I want to figure out what atom it is. This is important. Which subatomic particle identifies the element? It's the atomic number, and the atomic number is protons. So if you look at the periodic table, bam, it's atomic number 6. So it's carbon, right? Okay. Below or above carbon, just please quickly just write at least 6p and 6e. Here, I'll even do that with you. All right. What atom is negatively charged here? So again, I have 5 protons, 6 neutrons, and 6 electrons. So with 5 protons, I would have boron, right? Actually, it's not carbon anymore. I have changed the identity of my element. So that is boron. So what I want to write below, just quickly, I want to write 5 protons, and I have 6 electrons. All right, so then, taking a look at the final one, I have 6 protons, 6 neutrons, and 6 electrons. So what element is that? That's going to be carbon again. Okay, and I will type that in as well. 6 protons and 6 electrons. So just put that underneath. All right, so here's the big thing. We need to talk about how an ion, if it gains or loses electrons, it has an overall charge. So where does the charge go? Well, what we're going to do is over here we put the mass number. In the lower left, we had put the atomic number. In this case, it's not an isotope, it's an ion. So the charge is going to go in the upper right. It's the last spot that we need to worry about today. So in this first one, I have 6 protons and 6 electrons. So I have equal charge. Let's look at the boron. Which one do I have more of? I have more electrons, right? And it just said negatively charged. So I have one more negative than positive. So it would make sense that I have a -1 charge. And I wrote this wrong, didn't I? That was supposed to be a 5. I am sorry about that. That said 5 electrons right up here. For some of you realize that. So this has 6 protons and 5 electrons. So then the overall charge would reflect the fact that I have more positives than negatives. So I have one more positive than negative. So that's a +1. So why don't we pause this for a second and let's hand out the atomic structure 2 worksheet. So we'll just pause it. All right, so let's take a look. I'm going to do 4 of them with you. So please, you might need a periodic table. If you have one, that's great. Or just for all intents and purposes on this first one, we probably can just look at the periodic table on the wall. But you can use some of the Army or Navy ones I have up on the front table if you wish. So let's take a look. Okay, this is going to, again, give you some different pieces of information. So we're going to do 1, 2, 3, and 9. So what do I know and what don't I know? Well, this time I gave you the isotopic symbol. So here we go. I have a 2 and an H. Oh, I don't have a number in the bottom left. I kind of said that that was a redundant number because if I have the symbol, I already know that number. The atomic number matches up with the symbol. Excuse me. So let's take a look. What do I want to do first? Well, if I know what element this is, then what I'd like to do is I would like to put that in my proton. So it's H. So I look at the periodic table, and it has atomic number of 1. So I write a 1 there, right? Okay. What else am I doing here? Well, there's a lot of things here, but neutrons. How do I find neutrons? Well, neutrons and protons have the mass. So this upper left number even says here, symbol with mass number. So 1 plus blank equals 2. Well, 1 plus 1 equals 2. So 1 and 1. All right. Then we move over. Let's take a look at this right now. It says number of electrons, 1. And I have protons of 1. Remember that my protons are positive and my electrons are negative. So if I would actually write this right on top of my sheet. They're positive and negative, then I am good to go. And let's even do this. Mass, atomic mass, most of the time is going to be this. Protons plus neutrons. If you can write that above, that's great. All right, last, so atomic mass. Now, you have to be careful. You do not get to use a periodic table if you already know the mass. So in this case, I know the mass is 1 plus 1 is 2. So my mass number is 2. I know if you look at the periodic table, it says 1.00794, but that is an average. These are isotopes, so they have whole number masses. So that's going to be a 2. So then the final one is an ion. If it has a charge. Well, what's an ion? An ion has different numbers of protons and electrons. So I go over here, I look at my plus, I'm looking at my minus, I have 1 and 1, so they cancel each other out. So what I'm going to do is simply put just a mark. That's not a negative. That's like there's no ion. I'm not writing one. Okay, so let's look at number 2. We'll go through it in a, actually this one's very similar. So I have carbon. So right away, what does that tell me? Protons, right? Boom. I have 6 protons. All right, neutrons. How am I going to get that? It's not automatically 6 because this was 1 and 1. I look at the mass. So this time I have 14. So 14 basically minus the protons equal my neutrons. So 6 plus blank equals 14. So that should be an 8. So what's my mass number? Well, if I already gave you it, it's the same. So that's going to be 14. All right, and I didn't have to worry about an ion that time. Although I could have, again, figured it out because it was the same one. All right, a new problem with a little bit different information. So I have 14 for my mass with N, so nitrogen. So I look up nitrogen, and the periodic table says that's 7. So how many neutrons? What's the mass? These two are the mass. So 14, 7 plus 7 is 14. All right, let's jump over here because I already know 7 and 7. It's going to be 14 because of protons plus neutrons. But here's a new wrinkle. I have an ion. It says N, 3 minus. So what does that mean? That means I have more negatives and more positives. I have more negatives. It's 3 minus. So the minus tells me I have negatives. How many more? 3 more. What is hard for a lot of you is you're going to say, oh, I have 3 less, 3 minus. So you're going to look at protons and say, oh, I have 3 less. So I'm going to write 4. It's the opposite. I have 3 more negatives. So I have 10 electrons. All right, let's finish this up and then you can get to work. Let's go to number 9. Totally open-ended. Nothing else is on here whatsoever, except I did give you a mass and a symbol. So right away, actually, the easiest 2 of this whole problem is the mass and the information I can get from the symbol. So without even having to look at a periodic table, if I wrote 207 here, my mass on this thing is going to have to be 207. All right, what's the other thing that is more direct? It's going to be the protons. I look at the periodic table, and PB is in the lower right area of the periodic table, and that is element number 82. So I write 82. All right. Now what? Well, we need to figure out the neutrons. So mass is 207. So if I have 82 protons, 207 minus 82 is 125. All right. And then it appears I have not given you enough information because I haven't given you electrons or ions. So let's fix that right now. I'm gonna, please write this in. You had to know this one. Let's say 78. My fault. Hopefully there's no other ones like that. If there are, we'll fill them in. I have them all filled in the answer key. I must have realized there's a few mistakes on there. So if I have 78 though, right here, what does that mean? I need an ion. Why? Because I have a difference of positive and negative. So I have 82 positives, 78 negatives. So which one do I have more of? The positives. How many more? 4. So it's Pb4 plus. And that's how you're going to do it. So take your time. Let me know how it works. And we'll talk about it tomorrow as we kind of look more at isotopes.